Hi, I have Amiga CD32 with a CD drive that is able only to read audio CDs. It does not read game discs at all. My first attempt to fix this problem was replacing the pickup unit with a new one, but it did not improve actually anything. So the new pickup unit was also able to read only audio discs. Actually, I tried two different pickup units, model A and B. I had exactly the same problem. It would only read audio CDs. Now there are a few great tutorials on the internet how you can calibrate the CD drive, but it didn't work for me. So the problem was that I was doing something wrong and I ended up always with a setup which was able to read audio discs but no game discs. And based on those few tutorials, I figured out a new way how you can set up a drive, which in my opinion is a bit easier. So what we are going to do, we are going to divide this whole process into two main steps. There are in total 5 potentiometers that have to be set to the correct values. The one on the pickup unit, so that the laser diode has a proper power, and those 4 potentiometers. What we are going to do, we are going at first to set this potentiometer and those 2 potentiometers to a correct values. And there is a way that we can be sure that they are set properly, which means we can rule out those 3 potentiometers for the further settings, because we will be sure that their settings are correct. What will be left are those 2 remaining potentiometers over here, and now setting those 2 to a proper value is really tricky and really not an easy task. But what you can do on the end, you can run several iterations by probing or checking a different settings on those last 2 potentiometers until you get a stable reading of the game discs. But you will not have to go over all 5 potentiometers, because you will be sure that the first 3 potentiometers are set correctly. And this is the idea. This simplifies the whole settings a lot, because what you are going to do on the end is probably try a different setting of those 2 last potentiometers until you get a reading. But before we start, there's a quite important thing to do, and I will strongly suggest you doing it. So you have a drive, and hopefully you didn't play around with those potentiometers. So hopefully they are set to the values that were originally there. If that's the case, you have to make sure that if you screw things up and and your drive won't be able to read any discs, that you can put back those potentiometers to their original settings, so that your drive at least is able to read the audio CDs. Because that's the requirement. If the drive is unable to read audio discs, you won't be able to calibrate. And this is really not sufficient. What I did in the beginning here is just some marking so that I know where I have to put those potentiometers back. But they are those potentiometers are very sensible. So that is not enough just to make some markings on them or take a photo of their settings. That won't be enough to put them back to the correct position. What you have to do is just measure the resistance. Measure the resistance of those potentiometers to be sure that you can put them back where they were. Now this drive is calibrated, so the values that I'm going to measure are working in my case. Probably that would not work for you. I'm pretty sure that it will not work for you. I will tell you why in a second. So first I'm measuring the value of the potentiometer on the pickup unit. Maybe that's better. No. Okay. 413 ohms. This is the original pickup unit, because using the method that I will describe in a second, I was also able to bring back to life the original pickup unit. But as the laser diode is already old, I had to decrease the the resistance of this potentiometer. So it's quite low. Usually the new pickup units are about 1000 ohms, and this one is only 400 ohms. Okay, let's measure the resistance of the first potentiometer here. This is tracking error balance, TEB, and I mean, there are 3 legs, so I would suggest that you measure the resistance on both legs and write it down so that you have as many data as you can. 7.7K on the pin on the left and 13K pin on the right. Now we will move to second potentiometer. It's a focus error balance, FEB. Okay, the resistance is changing because there is a capacitor somewhere here, but just write down the first reading that you get, should be fine. 4.1, 4.1. Looks like it's exactly in the middle. Third potentiometer, tracking error gain, TEG, 870 ohms, and another pin, the right pin, is 3.63K. The last potentiometer, which is the focus error gain, 1.6K and 7.9K. Okay, now we have the values so that we can go back to the previous settings. Okay, let's start the calibration. My drive is already calibrated, so I will just play around with those potentiometers a little bit to remove the calibration, so it's not calibrated anymore, so that we can calibrate it in reality. Okay, step 1, we are going to calibrate tracking error balance. This is the first potentiometer when you look from the capacitor here. So we are going to set this potentiometer to the right value. In order to do so, we will be measuring the voltage difference between VF test point and TEO1. VF is a voltage reference, and we have to set the potentiometer to the position where the TO is as close as possible to voltage reference, which means that first we will power on the Amiga, do not put CD into the drive, set the multimeter to millivolts, connect one probe to VF and the other to TO1. It doesn't matter which one goes where. And what we are measuring here with the multimeter is a voltage difference between those 2 test points. So we have to set the potentiometer to the position where the multimeter will show lowest value as we can get. Okay, so let's turn it. Okay, that was the wrong direction. It doesn't make sense that I will point the camera in here because I'm turning it only a little bit, and it also doesn't matter in which direction you go. The value has to get lower. So if it's rising, then go just in another opposite direction. I'm trying to get it as low as possible. Those potentiometers are very sensitive. I'm barely touching it and it's changing already. Okay, this is 0.4 millivolts. This is 40 microvolts. That's really good result. As I said, there is a method to make sure that this potentiometer is set to the correct value. We just did it. Simple as that. The value is below 1 millivolt. That is sufficient. We are way below 1 millivolt. We are 0.4 millivolts. So we can be completely sure that this potentiometer is in the right position. So we don't have to bother with this potentiometer anymore. Now, step 2, we are going to set a focus error balance. That's the second potentiometer when you look from the capacitor. And this is exactly the same procedure. We are going to connect one end of the potentiometer to voltage reference and other to FEO, which is focus something. Because we are now setting focus error balance. And it's exactly the same game. Play around with the second potentiometer until you get here as low value as possible. Now I have 70 millivolts, which is really, I was going in the wrong direction, way too much. Ah, finally. This one is super sensitive. Trying to set a value as low as possible. Would be nice if I could go below 1 millivolt, but you know. I'm actually not moving this potentiometer, I'm touching it only. That's why I told you there is no point of taking a picture of it or writing a positions down, you know, marking something, because this is really not sufficient. Won't be enough to get this drive running. Oh, we are below 1 millivolt. So the second potentiometer is set to the proper value. Simple as that. Now we can be sure that the two potentiometers, so the tracking error balance and the focus error balance, are correct. We don't have to bother with those anymore. Now we are going to calibrate a laser diode, the power of the laser diode. For that we will turn this potentiometer on the pickup unit. The replacement pickup unit and the original pickup unit all are calibrated to read the original discs that have a silver layer, and the copies have a different color, like this one, so they do not reflect the laser beam as good as the original discs. And the CD drive is expecting a certain level of the data wave, and it's supposed to be around 900 millivolts peak to peak. So when you insert the original discs into the drive, then the signal that the pickup unit is delivering to the CD drive will be around 900 millivolts peak to peak. But if you insert the copy discs, the signal can be weaker, maybe around 750 millivolts or so, and that will cause some problems. So maybe the games on the disc copies will take longer to read, or the CDs will not read at all. Therefore, we are going first to calibrate this pickup unit using disc copy. Mine has a sine wave on it, but it actually doesn't matter. You can use any audio CD as a copy. Just insert the CD into the drive, power on your Amiga. Okay, close the lid. Should start spinning. I have only 2 songs on it. I will choose the second one because the first one is a silent wave, and I will play it in a second. Now to the test points. So we are using a scope for this calibration. Connect ground to a ground. I'm doing it right now. And the scope probe to RFO or RF0. And now I will move my camera to the scope so they can see what I'm doing on the scope. Okay, hit the play, so it plays sine wave. Let's see what we have here. Channel 1 coupling is AC. We don't care for a DC offset, just AC, because not. And the time base is okay. And the amplitude, I mean the time base looks fine. Now the triggering mode is set to normal, and depending on slope you choose, you might get a different wave. This doesn't really matter, because what we care for is voltage peak to peak, which is apparently right now about 500 millivolts, so it's way too low. previously I played around with those potentiometers to drop the previous calibration, so that's why it's so low. And just in order to measure it, I will use cursor, so we are pretty sure what we are getting there. I will, okay, just move it to the middle of the scope. Manual. And let's see what we have here. I mean, I'm expecting also to get about 500 millivolts, but just to be sure. Okay, that's the value over here. I'm not sure whether this can be. Okay. Now we are about 500 millivolts peak to peak. Skip to the second song. Now it plays. This track has only 1 minute, so I have to skip it. So I have to go back to it all the time. Okay, I will change the amplitude because we are going for 900 millivolts. So now, as you can see, it's 500 millivolts peak to peak. I'm going to increase the power of this laser diode. One very important thing. There is on some laser diode there is a seal, I mean drop of a paint or something, and you have to break it in order to be able to turn the potentiometer. I mean that there is the seal on the potentiometer. I mean, power of the drive, break the seal, put the potentiometer back to the position where it was, using the multimeter so that you can, that you can measure the resistance of what we have measured in the beginning, so that you can be sure that it's where it was. Because in order to break this seal, you need to apply some force, and maybe you will turn it too much clockwise, and turning it clockwise will increase the power of the laser diode, and you can just damage it if you go too far. Don't damage it, okay? Wait a second, stop playing. Doesn't want to play this audio CD. It has problems reading this disc. Come on, it was working a second ago. Here we go. 600 millivolts peak to peak. Now I'm going to turn it clockwise to increase the power. As you can see, it has really problems to read this audio CD because the amplitude was way too low. Okay. Skip the track. Okay, now place the second track. I increased the power. So as you can see, I was at 700 millivolts or so, and it had already problems to read this CD. Let's measure exactly what amplitude we have right now. I mean, voltage peak to peak. It's not an amplitude, it's a voltage peak to peak. Because that's what we're looking for. Okay, it's 1 volt. It's a little bit too high. I will go back to 900 millivolts. Okay. $950. I don't want to go too far because this will shorten the lifespan of this diode, and it's not necessary. And 900 millivolts is really totally enough. Okay. Okay, so the cursors are set. 880 millivolts. I will just apply a little bit more power to it, not much, by turning the potentiometer clockwise. If you're going anti-clockwise, you will decrease the power of the laser diode, and if you will go clockwise, you will decrease it. Alright, so this is all. Now we are where we are. All three potentiometers are set to the correct values, which I mean is the laser diode and the tracking and error balance. As you can see, it's really quite easy to figure it out that the values are correct because you just put the cursors on the scope in our case right now, and you can see that the strength of this wave. Now I will open the CD drive and remove this copy disk and put the original disk so that we can see what we will get with an original disk. As you can see, the amplitude of the original disk is a little bit higher, which is fine. That won't cause any problems. How much is it? Let's say 972 millivolts. Alright, those three potentiometers are set. Now we are going to the last part, which is going to be a little bit more difficult. Now we are going to set the last two potentiometers to proper values. This is the tracking error gain and a focus error gain. In order to do that, just insert a CD with the music into a drive and play the song number 1, so that the laser is as close to the center of the disc as possible, because then we will get not so much distortion. And so we are starting now with tracking error gain. This is the third potentiometer from the capacitor, TAG, and now I'm connecting the probe to TEO1. This is exactly the same test point as we had used previously to set a voltage reference to tracking error balance, but now we are setting tracking error gain, and we are looking on at we are interested in something different. So I will try now to set the scope so that we can see a little bit more of this waveform on the screen. So I am increasing the time per division to, let's say, 1 millisecond, and the voltage peak to peak is 100 millivolts. Now what I'm going to do, I'm going to turn this TAG, as a traffic error gain potentiometer, fully clockwise. Going clockwise will decrease the power going to the tracking coil. Tracking coil is responsible to move the laser diode or the lens back and forth so that it can stick to the track, so they can find the right track. And when you turn this potentiometer clockwise, you will decrease the power going through the coil. So if you move it fully clockwise, then the power will be as low as possible. Now going anti-clockwise will increase this power. So do not go too far anti-clockwise, because you might damage the coil. It just burns. And you should be actually able to hear that when the drive starts making a noise. That would mean that too much power is going to the coil. And what we are looking at is, now I will move my camera to the scope, because the interesting things will happen on the scope. So what we are looking at is we are going with this potentiometer fully clockwise, and then we will going back anti-clockwise very slowly until we reach a waveform that will not change anymore. Let's see what I mean by that. Now the potentiometer is on the clockwise ends, so to say, and now I'm going anti-clockwise, right? So I'm going back. The waveform is changing, and now I keep going back, but it's not changing anymore. I will not go too far because I don't want to damage the drive. Let's try it once again. I will go clockwise as far as it gets. You see it's jumping around, and now I'm going anti-clockwise until this waveform stabilizes and stops changing. And the idea is to turn it anti-clockwise as little as possible, but you have to hit the point when the wave is not changing. So you don't want to go too far anti-clockwise because that will put more current through coils, which is unnecessary. So we are right now at the correct position. Let's try it once again. We are going once again fully clockwise. It's jumping around, and now I will go once again anti-clockwise until I do not see any change. The waveform, which is around here, I guess. You see? And this is the proper position. Let's try it once again. I will move the potentiometer fully clockwise. It's jumping around, and I'm going anti-clockwise, and I get a stable waveform. And if I will keep going anti-clockwise, it will not change anymore. So you have to find a position when this waveform is not changing anymore and stay there. Okay, that was tracking error gain. Now let's try focus error gain. So I will move my probe to FEO1. And try to set a scope that the wave will fill up the whole screen. I will change the voltage per division. I will decrease the voltage per division. We are at 20 millivolts per division. And it's 1 millisecond per division, so I will try to increase time per division. Okay. So I think that 2 milliseconds per division and 20 millivolts is fine. Coupling is as well AC, and the trigger mode is normal. The same. Now we are going to change the last potentiometer because we are at tracking error in a focus error gain. So, and this is the same drill. So I will turn this potentiometer clockwise as far as it gets. As you can see, the waveform is jumping around. And now I'm going back until it stabilizes and it does not change a lot. That's it. I will try it once again, going fully clockwise. It's jumping around and it's, well, looks like you can see now I'm going backwards, so anti-clockwise, until I reach the waveform that is not changing anymore. Now if I will go too much, it starts changing, but it becomes unstable. So what I mean by that, you have to find as stable waveform as possible, and there is this period when you will turn the potentiometer and it will not change anymore. So going clockwise as far as it gets, now going backwards. I'm going backwards right now, and now I'm at the position when this waveform, I can turn the potentiometer in both directions, and the waveform will not change. So I suspect that we are in the right position. What I just figured out is that we are in the third track, and this introduces an extra error due to the fact that the CD-ROM is bouncing around if you go farther from the center. So I'm going to the first track, and we'll try it once again, because setting those potentiometers on the first track is just easier. Once again, I'm going fully clockwise. It's bouncing around, and now I'm going anti-clockwise. And this is what I'm getting. And now if I will keep going anti-clockwise, this waveform will not change. I mean, of course, I'm not going very far anti-clockwise. I mean, I can hear the coil is working here, so I move the potentiometer once again fully clockwise. Let's try it. That will be the last try. Fully clockwise, and now I'm going back. I'm going back. And I will stay there because it looks like going back doesn't make any sense because the waveform is not changing. That will be all, I guess. Let's see whether we can read some discs. Okay, remove that. Let's fetch some game disc. That's the original one. And then we'll try copy also. Reset. See what happens. The drive is spinning. Doesn't make any strange noises. Looks like it's just reading CD with no problems at all. And it loads again. That was actually proper time to load the game, so I think that it's fine. I'll hit reset again, open the lid so that I can remove the CD from the drive. And now we will try copy, which is here. Close the disk. And it should start reading. Nice, it's working. Have a nice evening, bye.